Hello student, welcome to your chemistry lab. Today I am discussing reaction mechanism part 7 of organic chemistry. Today I will discussing elimination reaction, that is E1 reaction or E1 mechanism. In previous class I have discussed E2 reaction or E2 mechanism. Today I will discussing E1 reaction mechanism, and it is important for JEE and NEET and also board, so read very carefully. Now we are watching the whiteboard. The E1 reaction, the dehydrohalogenation of CH3 with H2O to form CH3 C double bond CH2, that is alkene, can be used to illustrate the second general mechanism, the E1 mechanism, and reaction are given here. Alkyl halide eliminate by E1 via E1 mechanism form alkene and remove HI. Kinetics, the E1 reaction exhibits first order kinetics, that is rate equals to K into CH3 Ci. Like SN1 mechanism, the kinetics suggests that the reaction mechanism involves more than one step, and the slow step is unimolecular involving only alkyl halide. The E1 mechanism, the most straightforward explanation for the observed first order kinetics, is a two-step reaction. The bond to the leaving group break first before the pi bond is formed. So mechanism here, first step Ci bond is break, that is heterolysis of Ci bond form a carbocation, and it is a rate determining step because this step is slow. And next step, a base remove a proton from a carbon adjacent to the carbocation, and the electron pair in the CH bond form the pi bond. The E1 and E2 mechanism both involve in the same number of bonds broken and formed. The only difference is the timing. In an E1 reaction, the leaving group comes before the beta proton is removed, and the reaction occurs in two steps. In E2 reaction, the leaving group comes off as the beta proton is removed, and the reaction occurs in one step. An energy diagram for the reaction of CH3 Ci plus H2O is shown in figure. Each step has its own energy barrier with transition state at each energy maximum. Because its transition state is higher in energy, step 1 is rate determining state. Del G 0 for step 1 is positive because only bond breaking occurs, where del G 0 step 2 is negative because two bonds are formed and only one is broken. The E1 mechanism has two steps, so there are two energy barrier, and step 1 is rate determining step. The other characteristic of E1 reaction, first one, the rate of an E1 reaction increases as the number of alkyl group increases on the carbon with the leaving group increases. First 1 degree alkyl halide form 1 degree carbocation, 2 degree alkyl halide form 2 degree carbocation, and 3 degree alkyl halide form 3 degree carbocation. Here 1 degree to 3 degree rate of SN1 reaction increases because its form relative carbocation. We know that the 3 degree carbocation is more stable, so next increase the stability of the carbocation. Like an SN1 reaction, more substituted alkyl halide yield more substituted carbocation, that is more stable carbocation in the rate determining step. Increasing the stability of carbocation in turn decrease the activation energy for the slow step, which increase the rate of the E1 reaction according to Hammond postulate. Point 2. Because the base does not appear in the rate equation, weak base favor E1 reaction. The strength of the base usually determine whether a reaction follows E1 or E2 mechanism. Strong base like OH negative, RO negative favor E2 mechanism or E2 reaction, whereas weaker base like H2O, ROH favor the E1 reaction, that is E1 mechanism. Third, E1 reaction are regioselective, favoring formation of more substituted, more stable alkene. The Sedgwick rule apply to E1 reaction too. For example, E1 reaction of HBr from 1 bromo 1 methyl cyclopentane yields alkene AB. A having more substituted double bond is the major product, are showing that here 1 bromo 1 methyl cyclopentane have one halide and this carbon is called alpha, and 2 beta 1 carbon, and third one is beta 2. Beta 1, 2 beta 1 carbon is same, so it form that product A, that is the major product and tri-substituted alkene. And next beta 2, that is beta C carbon, is formed di-substituted alkene, is a minor product. Dehydration of alcohol. Dehydration of alcohol with concentrated H2SO4 at elevated temperature, that is 170 degree centigrade, follows E1 mechanism. Here tertiary butanol, it first protonated of alcohol weaken the CO bond and form protonated alcohol, and next here the removal of H2O give the carbocation, that is the 3 degree carbocation, which expels the proton to form more stable alkene, that is isobutylene. That is last step is deprotonation. The concentration of acid depends on the stability of carbocation. Since 1 degree alcohol gives unstable carbocation, it's require high temperature and high concentration of acid, while 3 degree alcohol requires lower temperature and lower concentration of acid for dehydration. For example, 1 degree alcohol concentrated H2SO4 at 445 Kelvin gives ethene, and where 3 degree alcohol concentrated in presence of concentrated H2SO4 at 363 Kelvin temperature form 2-methyl butane. Rearrangement in E1 reaction. E1 reaction involves the formation of carbocation intermediate. So before the loss of proton, rearrange can take place. The example is here 2 bromo 3 methyl 3 phenyl butane is given. So next here bromine is leaves in presence of methanol as a base and form 2 degree carbocation, and this 2 degree carbocation is less stable because here 3 degree or benzylic carbon is present. So here 1,2-methyl shift is possible, so it form 3 degree benzylic carbocation that is more stable than 2 degree carbocation, and next step is deprotonation from this alkene. It is the simple rearrangement of E1 reaction. Effect of leaving group. The rate of E1 reaction is directly related to the leavability of X negative, that is halide ion, which in turn is indirectly related to its basicity. The best leaving group, that is I negative, Br negative, Cl negative and F negative. Hence the order of reactivity is Me3Ci greater than Me3Cbr greater than Me3Cl greater than Me3Cf. Isotope effect. The CD bond is slightly stronger than CH bond by 5 kJ per mole. The reaction rate tends to be slower. If the CD bond is broken in the rate determining step, this effect is called primary isotopic effect. And this is the example. And first here 3 degree alkyl halide, all are hydrogen, and next it is 3 degree, here all are deuterium, all hydrogen are deuterium. In the above ion pair, rate of formation is found to be slowed down by 10% per d atom incorporated in place of hydrogen. This is known as the secondary isotopic effect because it is bond other than that carry the isotope level, that is containing the d atom is broken. E1 mechanism does not show 1 degree isotopic effect since no CH and or no CD bond breaks in the first rate determining step, but rate of reaction depends on the nature of surroundings group as Cx. The rate of reaction is slower if D is incorporated, hence the 2 degree isotopic effect. Hence it show 2 degree isotopic effect. Example, pH CH2CH2Br and pH CD2CH2Br react at almost the same rate with alcoholic NOH. It means they do not show 1 degree isotope, that is primary isotopic effect, and hence possessed by E1 mechanism. The slightly faster rate of E1 reaction of 1, that is pH CH2CH2Br, than that of 2 pH CD2CH2Br due to 2 degree isotopic effect. Effect of base. 3 degree alkyl halide react by E1 when the base is weak or has very low concentration. If the base is stronger or more concentrated, the E2 mechanism is prevails. If the base is very weak or very dilute, either R positive, that is carbocation, react with the nucleophilic solvent to give SN1 product, or in non-polar solvent Rx does not react at all. Effect of solvent. Stronger polar solvent facilitated the ionization and thus the E1 reaction is favored. I think you are enjoying to watch my video. I think you are understanding the E1 reaction or E1 mechanism, or also clear all the point. If are not clear, so comment me and I will be reply you. And next I will be coming with next part of the reaction mechanism of organic chemistry, that is E1CB reaction. So thank you everyone. Bye bye.